When we're talking about concentration of a solution, we usually describe it in terms of molarity, moles of solute divided by liters of solution. So then, what's the point of molality? It has a weird name, and it's all about kilograms of solvent. Well, molarity is more common, but there are some situations where molality is a better measure of concentration. I will talk about two of them. First of all, it is easier to make a molal solution than a molar solution. Here's why. If I want to make a molar solution, let's say I want to make a 1 molar solution, I'll take 1 mole of solute, I'll weigh it out, and then I will put it in a volumetric flask like this. There's a solute, I've dumped it here into the flask. Then I'll add a little bit of water to dissolve the solute. I'll swish it around, and then until it's dissolved. And then I will very carefully take additional water and fill it up to this line right here until it's exactly 1 liter. That can be kind of a pain because you have to have a good flask and you mix it together, and then you still have to add water to pull it up right here to the line. On the other hand, to make a 1 molal solution, all I got to do is take 1 mole of solute, I weigh that out, and then I put like a big bucket with water on it, on a scale or something, and weigh out 1 kilogram of water, and then I just pour in the solute and mix them together. That's all you got to do. So while molar solutions require more steps and special glassware that tells you the volume, 1 liter here, you don't even need a flask or a beaker to do a molal solution. All you need is a scale to weigh out the solute and the solvent and then mix them together. So that is one advantage of molality. Here is another advantage of molality. Molality stays constant over a wide range of temperature and pressures, whereas molarity can change. Let me show you how this happens. So let's imagine that right here I have a 1 molar solution, 1 mole divided in 1 liter of solution, and I've made this solution at 60 degrees Celsius. As I said, it's 1 mole in 1.000 liters. It's very precise. And 1 mole in 1 liter is going to give me a 1 molar solution. Okay. Now, here's the thing. You may not know this, but water and a variety of solvents can expand or contract depending on the temperature or the pressure. So if we cool things down to, say, 4 degrees Celsius, check this out. The water that used to reach the 1 liter mark here has now contracted so that I have less than 1 liter of solution here. And then on the other hand, at temperatures above 60 degrees, the water will expand. So instead of 1 liter here, now I have more than 1 liter of solution in this flask. So the volume has gone down here, but the amount of solute has not, because the solute's still just dissolved in the solution. So now I have 1 mole of solute, but it's only in 0.974 liters because the volume has gone down. And then on this, in this example here, where the water expanded, now I have 1 mole of solute in 1.025 liters because it went up. Since we get molarity by taking the moles and dividing the liters, this is going to change the molarity. So now in this situation, because I have less volume, so I'm dividing by a smaller number, my molarity is actually going to go up because the water contracted, and because the water, the solution expanded here, I get a smaller molarity. Now you could say that these aren't huge differences, and they might not be depending on what you're doing. But if you want to have a solution of very precise concentration, it could matter under certain situations if you have a concentration that is greater or less than 1 molar. On the other hand, while water can contract and expand, its mass will never change. So that means that if you have 1 mole in 1 kilogram of water at 60 degrees, even if that water expands, it will still weigh 1 kilogram. So I will have 1 mole over 1 kilogram of water at 98 degrees, so I also have a 1 molal solution here, like I had a 1 molal solution here. And again, if that water contracts a little bit, it's no big deal because the mass is still 1 kilogram, so I get a 1 molal solution. So it's constant no matter how the solution might expand or contract. So to sum this up, what's the point of molality? Despite the fact that it's sometimes easier to make a Molal solution, we can say that while molarity may change at different temperatures and or pressures, molality remains constant, and that can be a big advantage of Molal solutions.